Hey guys, welcome back. We're going to continue our study of trig. Do make sure that you download the app for Android or iOS, the GeoGebra Scientific Calculator. I'm guessing everything's going well because I didn't get a bunch of questions yesterday about trig. So we'll just keep going. There's not a whole lot of new stuff. We're just going to go in a little bit more depth and do a little bit of review at the beginning. So starting out, we already know with right triangles that the two sides that are next to the right triangle is going to be the legs, right? And then on the opposite side, that's going to be our hypotenuse. Now, when it comes to trig, one difference that we have is that we're always doing trig ratios with respect to an angle. In this case, we're going to be doing it with respect to angle x. Now, we don't call these legs just the left leg or the right leg or anything like that. We have to give them new names with respect to this angle. So we're going to call this the opposite leg, and this one, A, would be our adjacent leg. Now, if we move the angle down here, now A would be the opposite leg, and the B would be the adjacent leg. So those two would switch. But so we have opposite, adjacent, and hypotenuse. The hypotenuse is opposite of the right angle, the opposite is opposite of the angle, and then the adjacent leg is the leg that is next to our angle in question, but not the hypotenuse, because the hypotenuse is also next to the angle. All right, so here we have 30, 60, 90 special right triangles with a scale factor of 1, which is kind of like our unit circle version, and then the scale factor of 3, where everything got multiplied by 3. Now, what we notice is that the ratios of the sides are going to be exactly the same for the scale factor of 1 and for the scale factor of 3. And that's kind of the basis behind trig, is that the trig will tell us the ratio of the sides. Then the only question we have left after that would be, what is the scale factor? And that part comes into play whenever we do that, when we set them up. So sine of 60, if you remember, sine stands for the opposite over the hypotenuse. With respect to 60, opposite is going to be radical 3. The hypotenuse is going to be 2, so that's going to be rad 3 over 2. Then the cosine is the adjacent over the hypotenuse, which would be 1 over 2, so 1/2. And if you notice that 1/2 is the same as the sine of 30. So the sine of 30 is the same as the cosine of 60, which is kind of an interesting observation. That's just because we're going from the other side, right? And then the tangent would be the opposite over adjacent, which would be radical 3 over 1. All right, now we're going to do the same thing, but over here with the scale factor of 3. So it's the same triangle with the same ratios of their sides. They're just going to be scaled up by a scale factor of 3. So if we multiply the hypotenuse of 2 times 3 would now be 6, rad 3 is 3 rad 3, and then 1 is now going to become 3. So I've already got those here, and if we reduce them by dividing them by their scale factor, they'll go right back to where we started with the exact same ratios. And so if I take the ratios from over here, and I'll duplicate them real quick, and I'm going to move them over here, you're going to notice those are exactly the same ratios, which is kind of the power of trig, is that once we know what the ratios are for one of the triangles, then we know what they are for all of the scaled up or scaled down triangles. They all have the same ratios for sine, cosine, and tangent of any one of those given angles, which is really, really cool if you caught that. All right, so here we have a 45, 45, 90, which means it's similar to 1, 1, radical 2, so we could actually solve for this missing side. It's going to be basically, how do we go from radical 2 to 12? Well, we're going to multiply it. Let me go ahead and get this set up here. First thing we have to do is get rid of the radical, so we have to multiply it by a scale factor of radical 2. Rad 2 times rad 2 is now regular 2, and then regular 2 times what gets us 12? Well, then we have to multiply by an additional 6. So this side here, 1, would turn into 6 radical 2, which I think as a decimal is 8 point something. All right, so here in a calculator, we're going to do 6 radical 2. So 6 radical 2, and that's going to be 8.48. Okay, so x is equal to 8.48. We could also set this up with a trig function. So for sine, we have the sine of 45 is going to be equal to the opposite over the hypotenuse, which would be the opposite side of x over the hypotenuse, which would be 12 in this case. So that's going to be x over 12. It's also the same as 1 over radical 2, because these two are similar to each other, so they're going to have the same ratio. So when we're solving this, we also could see the sine of 45. Let me pull that up here. So sine of 45, if I do another input here, sine 45 is equal to 7.07. So that's going to be the ratio, which is exactly the same thing as 1 divided by radical 2. So that ratio is what we're getting whenever we say sine 45. That's going to be 7.07, and that ratio is equal to 1 over radical 2, or we could also say that it is equal to x over 12. So the only thing we have to do now to solve for x is to multiply that ratio times 12, which really is kind of like multiplying it by our scale factor. So if we multiply the sine of 45, and then we multiply that times 12, which would give us 12 sine 45, would give us the 8.48, which is the same thing that we had here from solving it with the special right triangle 1, 1, radical 2. All right, so another example here. This one's slightly different because now it's 44 degrees. So it's not going to be the same ratio we had before. We can't use a similar triangle. So we have to use our trig functions on this one. So we set it up with respect to 44. We have the opposite angle, and then the opposite side, and then the hypotenuse. So we are using the sine function, sine of 44. And then to figure out what sine of 44 is, well, that's just going to be in the calculator. So if we put this in here, sine 44. That's where we're going to get the ratio of 0.694, or if I round 0.695, and that's going to be the ratio of the opposite over the hypotenuse. And so to solve for x, all we'd have to do is multiply those two, so 12 times sine 44, which is exactly what we would do. So 12 sine of 44, which would give us the 8.336 if we round that, so 8.336. If you notice that value is going to be slightly smaller than what we had with the 45. So instead of the 45, we kept the hypotenuse the same length of 12, and we just decreased that opposite side by that small amount. So as we decrease the angle, the opposite side is going to decrease as well. So let me show you here. This is our trig table, which historically, if you didn't have a scientific calculator, this is how you would actually have to solve it, by looking these up. So the ratio of the sine of 45 is 7.07. That comes in our trig table. 45 is our angle, and then sine is going to be 7.07, which is the ratio of 1 divided by radical 2. Sine of 44 is going to be slightly less than that. Now it's going to be 0.695, which would be the sine of 44. Now all of these ratios are actually programmed into our calculator. So if we do sine of 44, so sine of 45 is the 7.07, sine of 44 is the 6.94. So these are all programmed into our calculator, so we don't actually have to use trig tables anymore as long as we have a scientific calculator. All right, so let's do an investigation of the unit circle. This is actually pretty cool. Looking forward to showing this to you. So here we have our circle, and what we want to do is we want to see let me move this up here a little bit here. So as we graph out this unit circle, the radius is going to stay the same. We're going to let the radius be equal to 1. That way it would be our unit circle. And then when we're graphing the cosine, it's going to be the adjacent length divided by the hypotenuse, which is 1. So what we're doing is, as we're increasing this angle, we're watching how does this x component change. So as we increase this angle here, the x component is going to go down. Once we get past this point, the x component will start getting bigger again on the negative side, and then it goes smaller again, then it starts getting bigger again, then we're back where we started. So what's really cool is we are actually graphing this out as we go. So we start out with a cosine of 0, which is 1. It's the largest that it's going to be. It's all entirely the x component. And then it starts trading off more towards the y component. And then by the time we get up to here, it goes to 0, the x component 0, and then it goes back to the largest that it gets over here, -1, and then we go back to 0 here, and then it goes back up. And this wave that it's actually graphing out is actually a sine wave, and there's a lot of, or a sinusoidal wave, and there's actually a lot of sine waves that are applications of sine waves that we use in physics. So it finds itself in the physical world all over the place, which is actually cool. Now, if we wanted to graph the sine wave, the sine just has to do with the opposite over the hypotenuse. And so now the opposite is going to be the vertical component here. And so how does that vertical component change as we increase the angle? Well, it starts out at 0, and then it goes all the way up to the highest that it can be, which is 1, then goes all the way back down to 0, and then -1, the lowest it can get, and then back to 0, back where we started. So, and then the whole thing's going to start all over again as we keep going around right back where we started, right? As cool as it gets graphed out as we go on the bottom here, you'll notice that the sine and the cosine waves are exactly the same. So graph the cosine, graph the sine. The difference is that it's shifted over by a period of 90 degrees, if I remember that. I was going to say pi over 2, if I remember right, in radians. But anyway, then the only other one that we have is the tangent function. Now the tangent function is the ratio of the opposite over the adjacent, and you're going to notice those two, they're trading off. And so it starts out at 0, and then goes all the way up to dividing by 0, which is infinite. So if you notice, the ratio of those two gets pretty big pretty fast. So we have an asymptotic behavior, and then it goes back to like a negative infinity, and then all the way back to 0, and then all the way back to positive infinity again, and the same thing over and over again. So we have that weird asymptotic behavior going on as we graph those out. So hope you guys enjoyed that. Let me go back to what we were doing before. All right, so on number 1, we want to set up our trig functions with respect to x. So our angle is going to be x in this case. So the sine of x is the opposite over the hypotenuse. So the opposite side of with respect to x is going to be 12. The hypotenuse would be 13, which means the adjacent would be 5. So the sine of x is going to be the opposite over the hypotenuse, which is 12 over 13. The cosine of x is the adjacent over the hypotenuse. So now the adjacent would be 5 and the hypotenuse is 13, so that would be 5 over 13. And then the tangent ratio would be the opposite over the adjacent, which is going to be 12 over 5. If you notice, all three trig functions are just relating two different sides together. You have the opposite and hypotenuse, the adjacent hypotenuse, and then the opposite and adjacent. Number 9, an escalator at a shopping center is 200 feet long and rises at an angle of 15 degrees. What is the vertical rise of the escalator? So if it rises at an angle of 15 degrees, it means our angle is down here. We would call this an angle of elevation because we're looking up instead of an angle of depression, which would be looking down. We'll talk about that a little bit more later. And then it says that we want to know the vertical rise of the escalator. Well, that's how high the escalator goes up. So that's going to be the x that we're solving for. And the escalator is 200 feet long. So that's going to be the hypotenuse length of the escalator, which is 200 feet long. So with respect to this angle, x is going to be the opposite side. The 200 feet is the hypotenuse because it's opposite of our right angle. So what trig function relates the opposite to the hypotenuse? So opposite and hypotenuse is going to be the sine function, right? So we're going to do sine of 15 is equal to the opposite over the hypotenuse, which is x over 200. Now, in order to solve for x, we want to get it by itself. We have to get rid of the division of 200, meaning we have to multiply both sides by 200. So we're going to put this in our calculator as 200 sine of 15. All right, so we're going to put in the calculator 200 sine of 15, which is going to give us 51.76, which will be our answer on the bottom on the answer bank. Number 11, a straight ramp rises at an angle of 25.5 degrees and has a base that's 30 feet long. So it rises at 25.5, so it would be an angle of elevation, and has a base that's going to be 30 feet long, so that would be the adjacent side here. Then we want to know how high is the ramp. So how high does the ramp go up, which is going to be x, which would be opposite with respect to the angle that was given to us. So we are relating the opposite and adjacent, which would be the tangent function. So tangent of 25.5 is equal to x over 30. And then to get rid of the 30, we have to multiply both sides by 30. And that's going to leave us with just the x by itself in this case. So I need to put in the calculator 30 tangent of 25.5. All right, which is 14.31. 14.31, so we can cross that one out on our answer bank as we go. That's how we know that we did it right. If you don't get one of the answers on the answer bank, it means that you set it up wrong, more than likely, or you put it in the calculator wrong. Look at number 15. So on this one, our angle is going to be 56, and then opposite of 56 is going to be our 31. This is going to be our hypotenuse. So what trig function relates the opposite to the hypotenuse? That would be the sine function. So sine of 56 is equal to 31 over x. Now, if you remember, when x is on the bottom, we end up multiplying both sides by x and then dividing everything by sine of 56. If you remember, we actually have a shortcut for that. So just go ahead and set up the equation, and then you can draw the shortcut by just showing that we're going to switch the place of those two, which means that x is going to go over here, and then the sine of 56 is going to go there. Essentially, that's what's going to end up happening, but you don't have to rewrite that. You can just write it as this. So when we put it in the calculator, it's going to be 31 divided by sine of 56. If we do it as a fraction, we need to do the n over d button first. So 31 divided by sine of 56, which is going to be 37.40. So 37, oh, I think I might have rounded that wrong. No, 37.39. Yeah, so it is 37.39. So we can cross that out on the answer bank. Number 16, we have our angle of 60 degrees here. Ooh, this is a 30, 60, 90. So we could actually use our special right triangle, if you remember that. So our longest side is 2, our shortest side, which is going to be opposite of our smallest angle, right? So shortest side is 1, and then this side here would be radical 3. So if this is 9, then this side over here has to be half of that, which means this has to be equal to 4.5. So that was actually pretty easy to do. Our scale factor, if you want to think about it, is 4.5, or 9 divided by 2. That was actually pretty easy to do, but let's set it up with a trig function. With respect to our angle, let me make sure we're only using one angle on this one. This is going to be our adjacent side. So we have the adjacent is x, and then we have the hypotenuse. So we're using the cosine of 60 is equal to x over 9. And then to get rid of the 9, we multiply both sides by 9. So we put this in the calculator as 9 cosine of 60. Which is exactly 4.5. Okay, nice. So we can cross that out on our answer bank as we go. All right, last one we're going to do is actually the law of sine. So up to this point, we've only used trig with right triangles, but we can actually still use trig to relate the angles and the sides to each other with the law of sine. So the law of sines is actually based on the triangle inequality theorem that says essentially the sine of the angle is going to be proportional with the opposite side of the angle, because we know the larger the larger the angle, the larger the opposite side. The smaller the angle, the smaller the opposite side. So these are all going to be proportional to each other, which is fascinating. This is true for all triangles, even if it's a right triangle or if it's an acute triangle like what we have over here. So the sine of A over A, so sine of 40 over 4 is equal to the sine of 60 over B, and which is also equal to the same ratio of the sine of 80 over C in this case, which is actually kind of cool. So to solve for the length of B, we set up, just looking at the first two parts, sine of 40 over 4 is equal to sine of 60 over B. Now to get B by itself, we just cross multiply, so we're going to get 4 sine of 60 divided by 40, and that's what I'm going to put in the calculator. Let me go ahead and clear this out so it's not so busy. I'm going to put it in as a fraction as well, so we're going to have 4 sine of 60 divided by the sine of 40, which is going to give me 5.39. So B is equal to 5.39. All right, next one we're going to do is to solve for C. So I already have my original one here of sine of 40 goes to 4, just as sine of 80 goes to C. So again, all I have to do is cross multiply and put this one in the calculator. So let me pull that up here. It's pretty much going to be the exact same thing we just did, except it's going to be 4 times the sine of 80. Over the sine of 40, which is going to be 6.13. All right, so then the final question, part C, asks if the triangle goes along with the triangle inequality theorem. So in this case, is our smallest side opposite the smallest angle? That's true. Is our medium side opposite the medium angle? That's true. And our longest side is opposite of the largest angle. That is true as well. That's actually a part of what makes the law of sines work, is that the ratio of the sine of the angle of the opposite angle is going to be proportional with the opposite angle itself, which is actually really cool. So you won't actually see the law of sines again probably for like 2 years till you take trig. But I wanted to go ahead and show you to you because it's really powerful and really kind of cool. We're not limited to just right triangles, but if we don't have a right triangle, we have to use the law of sines in order to solve for one of the missing links of the triangle. All right, so that's all that I have for you today. We did a much shorter video today and went into even more depth with trig. I'll probably give you guys a link to the PhET sim so you can check that out if you want to on your own, see how you can graph sine, cosine, and tangent. If you have any questions, please let me know. If not, I'll see you guys later.